Hello everyone, this is me Arijit with a new video, and in this video I'm going to show you how you can build a spider robot which will look something like this at the end, which can work like a spider with its 4 legs, and even you can control it with your smartphone like any other RC car. And even if you want, you can play with your pets too. And finally, it has its own dancing steps, which obviously is not that professional. So to build this thing, let's get started. So recently I was thinking to build one of these spider robots, obviously because they looks pretty cool. So I just went to Thingiverse and I just found some models, and this model looks pretty interesting to me. Now the problem with this model is the guy who made this has used something called Arduino here, and that particular board is not available in my country. Okay, so and also I want to use some basic Arduino Nano and a Bluetooth module and some servo motors to build this thing, and so I need to change the design obviously. And the second thing is the apps this guy has used doesn't exist anymore. I don't know why, but I just opened the links and those apps doesn't exist. So we need to also change the code so that we can use some other app with this robot. Okay, so that's why I came up with this model, and so this is how it looks like. As you can see, so this is the box. Inside this box we have all of my electronics components, and I'll show you how to build this. Okay, now if you want to build something like this, I will give you a step-by-step guide how you can build exactly a thing like that. All the STL files, all the codes, everything is open source, so you can just go to the site and just copy them. Okay, so the first step is you have to 3D print the body. Now if you have a 3D printer, so I have a Ender 3, so I have printed the body in my Ender 3. So if you have Ender 3 or something like that, you can do that. If you don't have any 3D printer, you can also use some online 3D printing services. Now when you are printing the bot, what things you need to print? So the first thing is, if you see here, this is the base of the body. So this is, you need to print a single piece of this one. Okay. The second thing is, this is the top cover. Also you need to print a single piece of this one too. Now this is part of a leg, and you need to print two pieces. Like this is so there are two parts here. Now you need to copy this thing twice and need to print this thing twice. Same for this, you need to print this thing twice and also this thing twice. Okay, and you need to print this thing only once. And finally, this is this is kind of the front leg, you can say, in my if you see here. Okay, so you can print it up, it's up to you if you want to print it or not. Okay, so this is about the 3D printing parts. Okay, the second thing is, all the codes you need are already available in my GitHub repository, so you can just go there, you can download it. Now there are 3 programs you can see. I will tell you which program do what and things like that. And finally, you need this RC control app to control this bot. Okay, you can use other apps also. I will also tell you how you can change the code so that you can use some other apps too. Okay, but in my video I'm going to use this app because it's free and it's pretty cool. Okay, so if you see in my Thingiverse link, I already have mentioned what are the parts I have used. So basically I'm going to use the Arduino Nano. The second, obviously Nano, because its size is quite small. The second thing is, we are going to use Nano expansion adapter breakout board. Now why? Because here we are going to use 12 servo motors. Okay, so that's why to connect all the motors with Arduino Nano, either you have to build a PCB, you have to solder PCB, else you have to use this expansion adapter. So I thought maybe so these expansion adapters are really cheap, so just buying one of these it makes your life a lot of easier. Okay, so you can just buy one of these and you can use it Arduino Nano. The third thing is, you need a Bluetooth module, so it could be a AC05, AC06. I am going to use AC05 here. And like I said, we need 12 servo motors. Now here we are going to use SG90 mini servos, so basically plastic gear servo motors. Now they are pretty cheap. So if you see, metal gear servos are quite costly, but these plastic gear servos are quite cheap. And if you are building a robot which is not going to carry a lot of weight, they will work just fine. Okay. Also, in my case, for my electronics part, you can use any battery, but I am going to use your 2 lithium ion batteries, and also I am going to use 5 volts. So I need to convert that voltage to 5 volts. So I am going to use a buck converter, which is LM2596. So again, you don't need to use that. If you have any other 5 volt battery, you can use that. Finally, I have used 2 LED batteries, blue LEDs, and finally some jumper wires. Okay, and some switches and other things. So this is all you need to build this thing. Okay, so after you will print the base, this is how it will look like. and after that you need to install the body shaft. So as you can see, like there are 4 holes in both of the sides, so you need to install 4 body shafts in all those 4 holes, and after that you need to install the servo motors. So as you can see, you need to install the servo motors in this way. Okay, and in the same way you need to install all the 4 servo motors in like both of the sides. Okay, and after you will install the servo motors, you also need to install the screws, and you are going to get the screws with the servo motor itself. Okay, and after that, after you will install all those 4 servo motors, this is how it will look like, as you can see. Okay, and in so yeah, this is how like at the end after you install the 4 servo motors. Now to give our robot power, we can use any 5 to 7 volt battery. As we know, like Arduino works in 5 to 7 volts, and servo motor also works in 5 to 6 volt around. Now you can use any 5 to 7 volt battery. Just make sure that your battery is capable of giving enough current to the Arduino, because as you know, Arduino is going to control 12 servo motors, so it will need a lot of current. Now here the configuration I am using, I am just using 2 lithium ion batteries in series. So basically it is creating 7.4 volts around. Then I am also using a battery management system for charging the batteries. And then I am using a switch to turn on the circuit. And after that, here this is a buck converter which is LM2596. Using this I am converting this 7.4 volts to 5 volts. And then I am going to give the 5 volts to my Arduino. Okay, and also I have a DC jack to like charge these batteries. Now you don't need to use the same configuration. You can use any configuration. You just need to give it 5 to 7 volts and like enough current. That's it. Okay. So here, as you can see, I have already attached the battery in this in the base of our robot, and also here is the buck converter which is LM2596, and in the back side, as you can see, I have connected this switch here and also the DC jack using which we can charge our battery here. Okay, and if you see, if I just turn on this switch, you will see that the circuit will be turned on, and from these 2 jumper wires we are going to get 5 volts and ground. We are going to simply connect this jumper wires with our Arduino, and our Arduino will get enough power, and also from the same source we are going to give power to the servo motors. So in this way this circuit will work. And now we need to see how we can connect the legs with the servo motors here. So let's see. Okay, so here to create a leg we need these 3 parts. Okay, so part 1, part 2 and part 3, and also we need 2 shafts, and we need also 2 servo motors. This is the all parts we need for a single leg. So that first you take the first part and you attach the body shaft there, and after installing the shaft, okay, so it's not that easy. So after installing the shaft, you need to install the servo. Now while installing the servo, remember that the gear part of the servo should be in the same side of the shaft. Okay, so it will look something like this. So the gear and the shaft will be in the same side in this way. So after you will like insert the servo here, you need to also attach the screws. Okay. So after you will install the screws, we are done with the first part, and then you can simply go to the second part. Now for the second part, there is nothing we have to do. For the third part, we need to do the same thing. At first we have to install the shaft, then we have to insert the servo motor, and finally we have to install the screws in it. Okay, in the same way. Okay, so after we will install the screws in this part also, our 3 parts are totally ready. Now we just need to attach 3 parts together, and it's really easy. You just insert the middle part to the shaft and the gear part of the first part, and in the same way you do the same thing for the third part also, and you will see it will be totally ready for you. Okay, so one leg is totally ready. Now remember one thing, don't install the cap right now. We are going to install the cap later, because we are going to initialize the legs with servos, and then we will do that. Now in this way you have to like create 4 legs in the same way, and after you will create the 4 legs, you will be ready to insert all the legs in the base of the body. So now we need to install the legs in the base. Okay, so let's start with one leg and let's try to insert it. So the direction of the leg will be something like this. So as you can see, the cap side of the servo, or like the gear side of the servo will be in the outer side of the body, as you can see here. Okay, so in this way you need to attach the legs here, and you just need to push it little bit, and then it will be inserted into the shaft and the servo gear. Okay, and here also we don't need to install the caps right now. We are going to install them later. Okay, and in the same way we need to install the legs for all the other 4 servos too. So after installing all the 4 servos, this is how it will look all the 4 legs, this is how it will look like, as you can see. And so yeah, and now we need to connect all the servo motors with the Arduino, and then we can actually program it. So here I'm going to insert the Bluetooth module in this gap. So here I'm going to use AC05 as the Bluetooth module, as you can see here. Now using this Bluetooth module, we will be able to communicate with our device using our smartphone. Okay. And as you can see, like in the here I have connected 3 jumper wires with the Bluetooth module. So I have connected one wire with the VCC pin of the Bluetooth module, which will go to the 5 volts in our Arduino. Another pin I have connected with the ground pin of Bluetooth module, which will go to the ground in the Arduino. And there is another pin which is a TX pin in our Bluetooth module, which will go to the RX pin of our Arduino. Because the Bluetooth module will transmit the data and our Arduino will just receive the data. So we will connect the TX pin of our Bluetooth module to the RX pin of our Arduino. Okay. And we don't need to connect anything with the RX pin of the Bluetooth module. Okay. As our Bluetooth module will not receive any data. So here I will insert it so that in future we can connect it with our Arduino. So here we are going to use the Arduino Nano, obviously because of its small size. And with Arduino Nano, we are also going to use Arduino Nano expansion breakout board. Now the reason is basically if you just connect this Arduino with the breakout board, then you are going to get all these pins like for each and every digital and analog pin in Arduino, you are going to get a VCC and ground pin with that pin. So basically the advantage will be that you can directly attach your servo motors in these pins. Like whereas if you don't use this breakout board, in that case you have to build your own PCB or like solder like wires to connect all the servo motors. But here you can simply take all the servo motors and connect them directly with it. So for example, like here if we just attach it, so if you see here, like in the back side, as you can see here, pin numbers are written. So you see here it is TX and RX, and in Arduino here here it is the TX and RX. So you can simply attach Arduino with this thing in this way. Okay, and after you will attach this here, as you can see, a 5 volt and ground pin. Using these 2 pins you can give it power, and in all these digital pins you are going to get a VCC and ground pin with them, and you can connect the servos directly with there. Also using a DC jack you can give power, and here there is a TX and RX pin with which we are going to connect our Bluetooth module. Okay, so now we have to connect the servo motors with our Arduino. Okay, now here we have total 12 servo motors. In each leg we have 3 servo motors and total 4 legs, so 12 servo motors. And in our Arduino we are going to use from digital pin 2 to digital pin 13. Okay, total 12 pins. Now the thing is that how we can connect the servo motors and how the numbering will be done. So if you see, this is the leg number 1. So if you see, this is the front of my robot. Okay, as you can see there are 2 holes, means 2 eyes. So this is the front of my robot. So this is leg number 1, this is leg number 2, this is leg number 3, and this is leg number 4. Okay, so this is the numbering of legs. Now in each leg we are going to consider this motor as the first motor, so the middle one as the first motor, this is as the second motor, and this one as the third motor. Okay, so basically this is the motor. So this is this motor will be connected to digital pin 2, this will be digital pin 3, this will be digital pin 4. Okay, so again I am saying, so this motor will be digital pin 2, this one digital pin 3, this one digital pin 4, then this one digital pin 5, this one digital pin 6, this one digital pin 7, then this one digital pin 8, this one digital pin 9, this one digital pin 10, then this one digital pin 11, this one digital pin 12, and this one digital pin 13. Okay, so in each leg we are going to consider the middle servo as the first, then this one, and then this one. Okay, and this is the leg 1, leg 2, leg 3, and leg 4. So in this way we are going to connect the servo motors with our Arduino pins. So here I am attaching the servo motors with the Arduino board. Okay, so basically with the shield. Now here you need to use the same pin numbering I just mentioned, because the code is basically written using those pins, and if you just connect one of the servos with some other pin, in that case you need to change the code. So if you want to use the same code I have used, in that case you maintain the same pin numbers I have just mentioned. Okay, so after you will attach all the servo motors with the shield, then the next thing is you have to connect the Bluetooth modules, VCC and ground pin with the shield. Okay, so in the shield if you see there are two 5-volt pins and two ground pins. So with any of the 5-volt pins, you just connect the 5-volt pin of the Bluetooth module, and with one of the ground pin, you just connect the ground pin of the Bluetooth module. Okay, and this is how I have connected. Now for now, you don't need to connect the RX pin of the TX pin of the Bluetooth module with the RX pin of Arduino. You don't need to connect it now. You will do it later. And after you will connect this, another thing you need to connect, which is you have to connect the 5-volt pin from the battery, for the 5-volt jumper wire from the battery to the 5-volt pin of the Arduino shield, Nano shield, and the ground pin from the battery to the ground pin of the Arduino Nano shield. So that from the battery, your Arduino will, like Arduino and all the servos will get power. Okay. Okay, so now the body of the robot is almost ready, and now we just need to upload few sketches. So I will, like, Arduino sketches. Now I will show you how you can upload those programs and what they will do. But before that, I just want to let you know that which program basically does what. So if you just open the GitHub repository, the link will be in the description, video description. So you can open that, and you will see there will be three folders. So one will be legs, one is program one, and one is spyder remote. Now the legs, so at first we have to, like, upload the leg sketch in our Arduino. So what this basically do, currently if you see all the servo motors, like, they are not initialized, so their position is basically random. Now we have to initialize all the servo motors to some specific positions, and the leg sketch will basically do that. So at first we have to upload the leg sketch, and then the servo positions will be then fixed, like it will basically initialize the servo positions, and then we are going to install the servo caps. After that, we will install the program 1. It is just for manual testing. So after uploading program 1, it will basically do some predefined steps, like going forward few steps, going backward few steps, like moving left, moving right, doing some dance steps and things like that. So already predefined some steps it will perform. So by that we will know that how our robot is basically performing. And if it is performing well, then finally we have to upload the spyder remote sketch, which is basically what, like, this is the main sketch using which we are going to control our robot using, like, our smartphone. So for the first two sketches, we don't need the Bluetooth module connected. Okay, so for the first one also or the second one also, the Bluetooth module must be disconnected. For the third one, after you will upload the third sketch, you have to connect your Bluetooth module with the Arduino, and then you will be able to control the robot with your smartphone. So let's see how you can upload the sketches and how it will work. Okay, so like I said, at first we have to upload the legs. So basically upload the legs sketch. So you just download all the codes, and from there you open the legs folder, and here you're going to get this legs Iono. So you just open that file in Arduino IDE, and like I said, here the pin numbers are mentioned too. So if you have changed any pin, you need to change it here. So after that, you go to tools and you select the board, you select the processor. So in case of board, it will be Arduino Nano. For processor, in my case, is Arduino 3288P old bootloader, but depending on your board, you have to select it. And finally, you have to select the port of your Arduino Nano, and then you can simply upload this sketch. So while uploading the sketch, make sure that your Arduino should be also powered through the battery, because after you will upload the sketch, Arduino is going to Arduino is going to initialize all the servo position. So if your board doesn't get enough current, then it will be not able to, like, initialize all the servo position. So make sure your board is powered through battery, and then you upload the sketch, and, like, after that you will see that all the servo will get initialized to, like, their, as you can say, their initial position. Okay, and after that we can install the caps. Okay, so here now, after you will upload the sketch, you will see that the servos will be initialized. Then you need to install the caps. So while installing the caps, make sure the first part of the leg should be totally straight with the body. So as you can see here, all the first part of the legs are totally straight with the body, and now we can install the servo caps. Okay, and in the same way, you have to install all the other servo caps one by one, and try to make the legs as straight as possible. So as you can see, in my case, this leg is was not that straight. So again, I am just removing it and trying to make it as straight as possible. So after you will make the first leg straight, the first part straight. After that, you have to work on the second part. For the second part also, you have to do the same. You have to again make it straight as possible, and you have to install the servo cap. And if it's not straight, you just remove it and you again attach it. And in the same way, you have to do this for the other side also. and for the third part of the leg you have to make it 90 degree with the second part. Okay, so in this way you have to attach the cap so that the third part will be 90 degree with the second part for the both sides. Okay, and this is how it will look like. And now in the same way you have to do it for the back side also. And in this way you have to attach all the to all the caps. So after you will attach all the caps, this is how it will look like. So as you can see, this is how it should look like after you will attach all these caps. And make sure that the battery should be like it should be powered while doing the whole process. So to verify that everything is okay, after you will attach all the legs, you can again upload the sketch, upload the same sketch and see if the positions of the servos are same or not. So here as you can see, I am again uploading the sketch, and as you can see, after uploading the sketch, the servo positions are totally same. So that means that my servo initialization is totally done. And then now we can go for the program 1 to test if everything is working fine or not. So we have to install the screws in the servo caps. Okay, so for the 12 servos you have to install the screws in each and every one. So you do that in this way. And after attaching all the screws, we will be ready so that we can upload our next program into it. Okay, so now we have to upload the program 1 sketch. So you go to the program 1 folder, and if you open it, there are total 3 files. Program 1 Iono, which is the file we are going to upload, and there is other 2 files which are flexitimer2.cp and flexitimer2.h. Now make sure these 3 files are in the same folder, and then you open this file in Arduino IDE, and you will see it will look something like this: program 1 and these are the 2 cpp and .h files. So they must be in the same folder, because here I have used these 2 files, like the flexitimer2.h file as a local as you can say local library. Okay, so that's why they must be in the same folder. And then you just simply again you just select the board, processor and port, and again you upload this sketch. So what this sketch will basically do is, like as you can see here, some predefined steps are mentioned. Like at first it will go forward, then backward, then left, then right, then it will do some hand wave, then it will give some body dance, and finally it will sit. So these are the predefined steps it will do. And after uploading the sketch, if you see your spyder is doing all these things, that means that everything is fine in your spyder. Okay, and if there are some problem in any of the steps, then you have to check your connection. Okay, so after you will upload the sketch, then if you just start your robot, this is how it should react. So at first it will stand, then it will go forward, and then it should go backward like we have mentioned in our code. And after that it should go left, and then it will go right. Now you can change the number of steps in the code. So as you can see, still now it is working fine. Then it should give you, I think, some hand wave. Okay, again hand wave, and now I think it should do some kind of dance. Yeah, and then finally I think it should sit. Yeah, so it is working just fine. Okay, so finally we are ready to upload the spyder demo sketch, and this is the sketch using which we are going to control our spyder with the smartphone app. Okay, now like again, while uploading this sketch, you don't need to connect your Bluetooth module with your Arduino. Okay, so after you will upload this sketch, then you will connect your Bluetooth module Arduino. Okay, so you just open this sketch, and this is how it looks like. Now here if you just see the sketch, so here basically we are using some serial data. So basically from the Bluetooth we are going to receive some serial data, and based on the data we receive, we are going to call some functions like step forward, step backward, and things like that. So the app I am using, for example, that app, when we press the forward button, that app sends F. Okay, so whenever I will listen F here, I am going to use step forward. So let's say you are using some other app, or maybe you are an iOS user and you have installed some iOS app in your phone, and your app is different, and your app is sending some different data while you have pressed the forward button. In that case, instead of this data equal to F, you have to write your own like if condition. Okay, and in that way you can like change the code and use it. But in my case, I am going to use the app. I will show you which app I am using, and you can use the same app. For that app, you can use simply this code. You don't need to change anything. So again, you just select the board, poisson and port, and you just upload the sketch. So after you have uploaded the sketch, now we have to connect our Arduino with the Bluetooth module. Now remember, in our Bluetooth module, we have connected a jumper wire with the RX TX pin with our Bluetooth module. Now we have to connect that TX pin of our Bluetooth module to the RX pin of the Arduino. So basically, if you see in the shield, there is a RX pin, and you have to connect the pin with this pin. And after that, you will be done. And finally, we have to install the top 3D cover, and here I am going to use some M3 screws to install the top cover. And after installing the top cover, we will be done with like assembling the body. And finally, we just need to install the Bluetooth app, and we have to test how our spyder is working. Okay, now let's check our spyder with the Android application. So at first you have to turn the device on. So let me turn it on, and after turning it on, you will see that the servos will be initialized. Then you have to open the Bluetooth in your smartphone. Okay, and as you can see here, and in the available devices, you will see HC05. So you click on that and you pair with that. So here for the passcode, you use 1234 and you click OK. And within very few seconds, you will see HC05 will be paired. After that, you have to open the Android application. The link of the application will be in the description so that you can download it from Play Store. And this is how it looks like. So at first you have to connect it with the spyder. So you go to this option. From there you select HC05, and like within very few seconds it will be connected. So as you can see here, it's green. That means it has been connected with the device. And now to stand the spyder, you have to click in a triangle button. And also I have connected to LEDs with the analog pin 0. And so to turn the LEDs on, you have to click in the headlight button. And then controlling the bot is quite easy. You have just, so for example, if you just click forward, it will go forward. If you just click backward, it will go backward. If you just click in the left button, it will go in the left, it will rotate in the left direction. If you click in the right button, it will rotate in the right direction. And also, except that there is a backlight option. If you just click in the backlight, it will start dancing, as you can see here. And then there is a horn option, as you can see. So if you just click in the horn option, it is going to give you a hand wave. And finally, if you just want to make it sit, you just click in the triangle button again. Okay. And also by clicking the headlight button again, you can turn off the LED too. Okay, so as you can see here. So in this way, you can control this spyder using all the options available in this app. Okay guys, so this is all about this project, and if you have any issues with this project, you can let me know in the comment section. Also, you can mail me, and I am planning to upgrade this project. Maybe I'll add a Raspberry Pi and maybe some cameras and some image processing, things like that. Maybe I will do all this. And also I am also planning for this kind of more projects in future, so stay tuned for this kind of videos. And if you have liked this video, in that case hit the like button and subscribe to this channel. So that's it for today. See you in the next time.